A class of students investigate the power output of each student in the class. The class must decide whether they use a method using steps or a method using weights. The whole class must use the same method. Plan what measurements the student should take and how. So this is really important. This is what you're being asked to do. What measurements the students should take and how these can be used to calculate and compare the power output of each student. So you need to use these measurements to calculate power output and then compare for each student. So that's what you're being asked to do. To get full marks, you need to reference all these points. It's not actually that hard, but you just need to think about it. So firstly, how do you work out power? Well, power is an equation. It's power equals energy transferred divided by time. So it's the amount of energy you transfer in 1 second. The more energy you transfer, the more powerful you are. So to work out, and this is right, you can measure time quite easily in a experiment, but what you can't so easily is energy. How do you work out energy transfer? Well, energy transfer is the same as work done. And work done, when we transfer energy, we do work. So we say it's work done. Work done is distance times force. So it's the distance you move a force. If you move a force or you apply a force over a certain distance, you are doing work. So lifting a weight is applying a force over a certain distance. So force, remember, is mass of something times the gravitational field strength, or it would be if you're talking about weight anyway, and weight is a good force to look at here. So we're basically trying to find the weight of something, mass times gravitational field strength. So there's quite a lot of things to tie in, but this is for top answers. You can still easily access this question to get a few marks. So here's one idea. You could get basically different students to lift weights up a certain distance. So you measure a distance, let's say a meter on a ruler. So let's say you timed that for a minute. You'd have to work out the distance they move it. So that'd be 1 meter, 2 meters, 3 meters, 4 meters, 5 meters. The weight would stay the same. So you'd multiply at the end of the day the weight by the total distance you move that weight upwards, not downwards, because you're not doing any work, you're letting gravity do the work, but upwards is important. So once you've done that, you've got work done, and then you divide it by the time it took in seconds. So if it was a minute, it'd be 60 seconds, and then you do the same for the rest of the class, and you'd compare the results to see who transferred the most energy in a second. The one with the highest energy would be the most powerful. So here's an example of how you could do this, but you could do this in a number of ways. And look how I've drawn a diagram, because you can get marks for that. So different students lifting same weight in a set time, you could do that. So the apparatus you need is weights, a ruler, and a stop clock. The measurements you take, for example, the weight lifted, how heavy, you'd have to make sure that it's of the same weight, the heights lifted, and the time taken. So that's how you get the measurements. Then use the work done formula. So work done equals force times distance, and the power equation, power equals work done divided by time, and that will tell you how you calculate, how these can be used to calculate the power of each student. So we've dealt with measurements and now power. Look how I'm bullet pointing this as well. You can do that and then compare the results between the students, okay? And that will get you the marks.